All right, and welcome back. In this video, we are going to be going through Chapter 6, Section 5, which is titled Inequalities for Two Triangles. Previously, we talked about inequalities for one triangle, but in this section, we'll be talking about inequalities for two triangles. And by the end of this video, we should be able to state and apply the inequality theorems, again, for two triangles. So let's have out our guide and notes. Let's begin. So on the right-hand side, we have a diagram depicting the current situation that we're going to be talking about on the left. And it says the next two theorems compare two triangles. Even though the triangles are not congruent, the theorems allow you to draw conclusions about the lengths of sides and measures of angles. Both theorems are long, but their ideas are very simple. So let's suppose you have two pairs of hinged sticks, with segment AB being congruent to segment XY, so that's AB congruent to XY, and AC congruent to XZ. So AC congruent to XZ, all their lengths are equal. If you open them so that the measure of angle A is greater than the measure of angle X, you can see that segment BC, its length is now greater than the length of segment YZ. This is called the side angle side, or SAS, inequality theorem. And likewise, suppose you have the same two pairs of hinged sticks, with again the length of AB equaling the length of XY, and the length of AC equaling the length of XZ. If you open them so that BC, its length is greater than the length of XY, you can see that the measure of angle A is greater than the measure of angle X. This is a side-side-side inequality theorem. We use side angle side when we are given that included angle. So it's side angle side. But we use side when we are given the relationship of that third side. Side angle side allows us to determine or conclude the length of a third side. Side allows us to determine or conclude the included angle, or the opposite angle of that third side. So it does get a little bit tricky with its application, so just make sure you are paying close attention to what you are trying to prove. So again, side angle side inequality theorem, you can call it side angle side inequality theorem. That's totally fine. If two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle for the second, then the third side of the first triangle is longer than the third side of the second triangle. And likewise, side inequality theorem. Again, you can call it the side inequality theorem. That's totally fine. If two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. Let's go through an example. So we're given two separate diagrams. We have diagram A and diagram B, and we're asked, what can you deduce? Name the theorem that supports your answer. So over on the left-hand side, I notice that JK is congruent to NM, JL is congruent to NO, and LK has a length of 5, and OM has a length of 6. Well, I have two pairs of congruent side lengths. I'm given that third side length, and we should be able to conclude either the measure of angle N or the measure of angle J, because those are the included angles of those two congruent sides. Well, we're able to say that the measure of angle N is greater than the measure of angle J because, again, OM has a value of 6, LK has a value of 5. So this would be by the side inequality theorem. The side allows us to determine or deduce the included angle of a triangle between those two pairs of congruent sides. Diagram B is a little bit more complicated. We have to do a little bit more algebra and a little bit more thinking, but it's okay, can do it. Well, we're given that the value of angle EGF is 39 degrees, angle F is 44 degrees. We see that DE is congruent to EF. They both have a value of 4. We also know that segment GE is congruent to itself because of the reflexive property, so we're going to have to find angle 2 and angle 1. Well, angle 2 is going to be equal to 180, take away the sum of 39 and 44. Angle 1 should be equal to the sum of 39 and 44 because 39 and 44, those are two remote interior angles, and angle 1 is an exterior angle. So as we figure all that out, it's going to allow us to deduce some information. Well, Once we do that, we see the included angles. Angle 2 is equal to 97, and the measure of angle 1 is equal to 83. So, since the measure of angle 2 is greater than the measure of angle 1, that means that GF, this side length, has to be bigger than GD, that side length, again by the side angle side inequality theorem. We use side angle side to help us determine that third side. But we use side to determine the angles. So again, it does work a little bit backwards. So we have to pay attention to what we're trying to prove and how we're going to prove it. With this in mind, please work on problems 1 through 13 on the guided notes. Great job with this. Keep making yourself proud. Please let us know if you have any questions, and we'll talk to you soon.